In this lesson, we're going to take a look at standard and factored forms. So we've already talked about standard form and graphed from a table of values using standard form and substituting in various x values in our previous lesson. So we'll start with that here. We have y equals x squared minus 6x plus 5. And if you recall to come up with our y values, we simply substitute each x value into this equation. So we can rewrite the equation, and instead of an x, we can put in a bracket, and inside of the x, we can substitute in an x value. So 0 squared is 0, minus 6 times 0, which is 0, and plus 5. 0 minus 0 plus 5 is equal to 5. And we can keep doing that with each value of x to solve for our y values. So once we have our table of values filled in, we can plot our points here and we can see our parabola shape for this quadratic. Now we'll take a look at this version here, which is called factored form. So here we have y equals x minus 5 times x minus 1. And we can do the same thing to figure out our table of values. So if I substitute in a 0 here and here, where the x's are, 0 subtract 5 is negative 5, and 0 subtract 1 is negative 1. And these are being multiplied, so negative 5 times negative 1 is equal to positive 5. So I've already done that with each of these to get our table of values and plotted the points as well. Now if we compare these two quadratic relations, y equals x squared minus 6x plus 5 and y equals x minus 5 times x minus 1, we can see the exact same parabola. If we look at our table of values, we have the exact same y values for each x values. So what we can say is that these graphs are the same. So although they look like they have a different equation, it is actually the same equation in a different form. Now, if you recall from our last unit, we learned how to multiply binomials, and when we do that, we take the first term in the first binomial and multiply it by each term in the second binomial, and then we take the second term and multiply by each term in the second binomial. So that gives us x squared minus 1x minus 5x plus 5, and if I collect my like terms, minus 1x minus 5x is equal to minus 6x. So x squared minus 6x plus 5, that is the exact same as this equation. So the two equations I have here are just in different formats. So this is called standard form and this is called factored form, and that's what we're going to take a look at in this lesson. So standard form, this one we have already talked about before. As standard form, y equals ax squared plus bx plus c. So we're going to take a look at, we've been identifying various key features of parabolas, of quadratic relations, and here we have equations in standard form and the quadratic relation when it's graphed. So we're going to see if we can notice anything from the equation and the graph. So over here I have a is equal to a positive 1, b is equal to negative 4, and c is equal to positive 3. So a is whatever number or coefficient is in front of the x squared, b is in front of the x, and c is the constant. So key features, we have our y-intercept here is at 0, 3. We have an x-intercept at 1, 0, and another one at 3, 0. And our vertex is at 2, negative 1, and our axis of symmetry would be at x equals 2. Now there's nothing to do with a 2 over here, so this equation doesn't have anything to do with that. I do have a 3 here and here, so let's take a look at our next quadratic relation and see if we notice anything. So here, a is a negative 1, b is negative 4 again, and our c is a negative 6. So we have a y-intercept here, which is at 0, negative 6. There are actually no zeros in this question. And our vertex is at negative 2, negative 2, it looks like. So once again, nothing to do with the vertex in here. But I do have a -6 here and a -6 here, so it looks like my y-intercept may be related there. And here I have a 3 and my y-intercept is a +3. So it looks like there may be a connection between my c value and my y-intercept. So let's investigate that further and see if we notice anything. So +9 is our y-intercept at 9, and it looks like it is. So at 0 and 9. So there is our connection between standard form, and here we have a c of +3, and if I go to my y-axis at +3, sure enough, whoops, writing that backwards here, not 3, 0, but 0, 3. There we go. So what we see is that the c value tells us the y-intercept. So this is where standard form is helpful. It will tell us the y-intercept of our quadratic relation, so we can graph that point of our parabola. Now over here we had an a of +1, this was an a of -1, and if I look at these parabolas, this one opens up and this one opens down. So let's see if we have any connection here. Here our a is positive, it's +2, and here our a is a negative again. So a positive opens up, positive, this also opens up, negative opens down, negative opens down. So that's our next connection, is that our a value tells us the direction of opening. So standard form is useful to us, ax squared plus bx plus c, because the a will tell us if our parabola opens up or down, and c will tell us where that parabola crosses our y-axis. Now, that is not enough information to graph an entire parabola, and so in the last unit we learned how to go from factored form to standard, but also how to go from standard form to factored. And that's going to be helpful because each form tells us different pieces of information. So we're going to now investigate factored form, which the general equation for that is y is equal to a times x minus r times x minus s. Now once again we have an a here. That's the exact same letter used as in standard form, and that is because as we go from one form to the other, that number is actually going to be the same number. So in the last one we learned that the a tells us if we open up or down. Here I have nothing in front of here, which means that it's a +1. A is positive and it opens up. Here it's negative and opens down, positive and opens up, negative and opens down. So that is the exact same as before. Our a value gives us the direction of opening. So once again, it's the exact same number and sign we would have as we move from one form to the other. So the r and the s, we want to investigate what those might mean. So here I have an x minus 3 and an x minus 1, and my zeros are at 1 and 3. So these are the same numbers, but this is a +1 and a +3, but I have x minus 3 and x minus 1. So I have the right numbers, but the signs are opposite. So let's keep looking here. Here I have a -5 and a -3. And once again, I do have the same numbers, but it's x plus 5 and x plus 3. Here my zeros are -5 and -1, and I have a +5 and a +1. And here I have -1 and +3. So the -1 I have a +1, and the +3 I have a -3. So if we look back to our equation, this says x subtract whatever r is. So when I have x subtract a number, this is telling me that my r is equal to 3, and my 0 here, one of my x-intercepts, is equal to +3. when my r or my s is a negative value, so here my 0 or my x-intercept is -1, so because it's x subtract s, if s is a -1, so if s equals -1, I'm subtracting a -1, it becomes x plus 1. So when we look at factored form, we need to be careful that the general equation is x subtract our 0, which means if we have a subtraction, our value for our 0 is actually a positive number. And if we have an addition, it was a negative. The other way we can look at this is our y value for each of these. Our y value is always 0. So when I'm touching the x-axis, I have not shifted up or down from my origin. So y is equal to 0. And in this format, I have, if I look over here, a times whatever this bracket is times whatever this bracket is. So in order for y to equal 0, now a is going to be a number, and so a cannot impact our answer of 0. So that means either this part has to equal 0 or this part has to equal 0. So that means x minus r has to equal 0 or x minus s has to equal 0. So if we take one particular example over here where I have x plus 5, if x plus 5 equals 0, well, when does that happen? If I take this plus 5 and move it over, remember when we solve equations, to move something to the opposite sign of the equal sign, we have to do the opposite operation. So this is going to be a 0 minus 5, which is equal to -5. So to end up with a 0 in this bracket, -5 plus 5 is equal to 0, and once I have a 0 in here, 0 times anything else will give me my y value of 0. So to have -5, 0 over here, I need a -5 plus 5 to equal 0. So in factored form, the r and the s tell us the zeros. But once again, we have to be careful that it is not the sign in front of here, but the opposite for the actual value. So let's give these a try over here. So in all of them, we get the direction of opening from that a value, whether we're in factored form or in standard form. So over here, my a is a +2, so positive a value means my direction of opening is up. Over here, it's a negative, so that one is down. This is positive, so it opens up. A is negative, so it opens down. A is negative, so it opens down. And A is positive, so it opens up. So whether we are in standard or factored form, we can tell the direction of opening from that A value being negative or positive. For intercepts, we can get our y-intercept in standard form, and remember that's just our c value. So our y-intercept happens when x is 0, and then in this case y is -4. This is our next one that's standard form, so this +7. So 0 and, whoops, not -7, 0 and 7. And over here we have 0 and -10. So standard form gives us our y-intercept. Now, factored form we just looked at, this gives us our x-intercept, but we need to make this equal to 0. So what +1 is 0, -1 plus 1. So when x, whoops, not x, this time y is 0. So a -1 for x, -1 plus 1 will give us that y is 0, or a +3 minus 3 is equal to 0. So over here, a -8 plus 8 equals 0. So -8 is 1, 0, and for this one, 2 minus 2, so to 0. And in our last one, 9 minus 9, so it'll happen when x is a positive 9, and 1 minus 1, so we have positive 1. So that is how we can use both standard and factored forms to get different key features of our parabola.